Hello everyone, welcome to the talk entitled Algorithms of Air Quality Estimation, a comparative study of a stochastic and heuristic predictive model. This work was done by Nadia Sanchez along with some professors and researchers and the Smart Data Analysis Systems Group's ESDAS group. This is the outline that we'll go over. First, introduction statement, the motivation and problem statement, materials and methods, results and discussions, and finally conclusions and future work. This paper presents a comparative of predictive models applied to air quality estimation. Currently, among the most remarkable global issues, we can mention the high concern about air pollution. Nowadays, we count on several air quality indicators, being the concentration of carbon monoxide, sulfur dioxide, nitrogen dioxide, and ozone the most important ones. When the concentration level of an indicator exceeds a certain air quality safety threshold, breathing such air is considered harmful to human health. That is why, in cities like London, there have been implemented monitoring systems for air pollutants which generate concentration level data. This study aims to compare the efficiency of stochastic and heuristic predictive models on the forecasting of ozone concentration to estimate London's air quality. This is done by analyzing an open dataset retrieved from the London Data Store portal. Research has benefited the development of efficient algorithms bringing new knowledge to science and technology. For this reason, this paper compares the efficiency of stochastic and heuristic predictive models in forecasting the concentration of air pollutants to estimate London's air quality more accurately. The forecasting methods compared in these papers are classical such as autoregressive integration moving average ARIMA and other more sophisticated ones like random forest, artificial neural network-based ones, support vector machines, and support vector regression. This paper was retrieved from the open portal named London Average Air Quality Levels. The dataset consists of 16 variables and 3,336 measurements that were recorded every hour. It is worth mentioning that there are no records for some variables such as nitrogen oxides. In addition, data holds outliers. After performing a correlation analysis of variables, it is observed that some variables present multicollinearity. The variable O3, ozone, is the least correlated with data. Particularly, the data analyzed in this study are the hourly measurements of ozone, O3, over which the predictions are made. This study, the data used to generate the model were those corresponding to the years between 2008 and 2018, and the data used to estimate the quality of the model were those corresponding to the last 12 months from August 2018 to July 2019. The last 12 months correspond to the 8% of the total of the sample, which is enough to evaluate the predictive capacity of the model for the last year. Figure 1 shows the distribution. This figure shows the distribution of the data, the train set in red and the test set in blue. This study was developed under an experimental methodology consisting of data selection and preprocessing. Next, the predictive model selection, then the model training, and finally the comparative analysis with other available models. ARIMA is one of the most typical linear methods for time series forecasting. This model uses the existing variations and regressions across the data to determine the intrinsic patterns in the series, and from then it can perform the forecast task. This model is characterized by its low computational cost while its performance depends on few parameter settings. To quantify its performance, errors must be estimated period by period once the model is fed to the data. On its side, nonlinear SVR models have been widely used to predict time series. SVR allows the use of functions called kernels that consist of the nonlinear mapping in the feature space. A kernel should satisfy the Mercer's theorem, and some kernels are specified here in this slide, like kernel Gaussian, TRBF, triangular kernel, and trapezoidal kernel. Uh, Profit is an open source software procedure for forecasting time series based on an additive model where nonlinear trends are adjusted for annual, weekly, and daily seasonality. This approach was released by Facebook Core Data Science team, and it's a robust to it's an approach robust to missing data and trend shift, and it can handle with outliers well. Profit is an additive regression model with four components: trend, yearly seasonality, weekly, and important days. Recurrent neural networks is a type of neural network used to process sequential data. Uh, long short-term memory LSTM compensates for the problems of vanishing gradient, exploding gradient, and insufficient long-term memory of RNN. It can make full use of long-distance time sequence information. LSTM is a special type of RNN consisting of an input layer, an output layer, and a series of recurrently connected hidden layers known as blocks. In neural networks, parameters must be defined at the beginning of the training process, such as the number of hidden layers in nodes, learning rates, and activation functions, among others. The LSTM model detected all the existing peaks in the testset, which indicates a good prediction. That prediction follows precisely the trend of the original series. The predicted values for the first peak are still above the test values, but they are significantly better compared with the Facebook Profit model ones. The root mean square error RMSE, mean absolute value error MAE, and the mean squared error MSE were used as evaluation measurements to assess the accuracy of the predictive model. While mean absolute percentage error MAPE was used for the selection of hyperparameters. The metrics calculated in each predictive model are presented in this table. As can be seen, ARIMA SVR neural networks models have the ones reaching uh, RMSE values less than 1. Therefore, they are models with better accuracy. Compared with the ARIMA and the Facebook Profit models, the SVR and neural network models capture the spatial-temporal correlation more effectively, as well as they reach better prediction performance. In this paper, we compare different stochastic and heuristic predictive models applied to air quality estimation, since several alternatives are currently being studied to counteract the environmental pollution problem. Thus, predictive models aiming to anticipate high pollution scenarios are generated. In this case, artificial intelligence techniques, especially those related to time series prediction, have been proven to be of great benefit to the automation of air quality estimation processes. After the application of the four predictive models to predict the concentration of air pollutants based on historical data of pollutants concentrations, especially ozone, the results indicate that the models with the best predictive capacity were the ARIMA model and the neural network model. More suitable optimizers and parameter tuning approaches will be explored by considering more sophisticated techniques. Also, significant statistical tests for measuring the differences of the results obtained are to be carried out. Future developments can be addressed on one hand to evaluate other neural networks architecture combining hyperparameters to improve the accuracy. This work was supported by ESA's research group. And thank you very much for your attention. Don't hesitate to reach out through our contact information. If you have any question, we would happy to reply and address all your concerns and queries. Thank you again.